we're going to talk about simplifying square roots. So when you're simplifying square roots, the first thing you want to do is look for any perfect squares. Okay, so let's do some examples of perfect squares. We know that 36 is a perfect square. It's 6 times 6, or 6 squared. 49 is 7 times 7, or 7 squared. 144, 12 times 12, or 12 squared. We also can look for things like perfect square expressions. So x squared is a perfect square expression. It's x times x. Y to the 8th is a perfect square expression. It would be y to the 4th squared. W to the 10th can be broken down to a perfect square expression. It would be w to the 5th squared. So these are examples of perfect square expressions, and so are these. So when you're breaking down square roots, you want to look for not only this, but also this. So let's look at some examples. 64, x to the 6th, y to the 10th. So what you want to do first is break this down into pieces that are perfect squared. So I know that 64 is 8 squared. Leave my square root there. And x to the 6th is the same as x to the 3rd squared. And y to the 10th is the same as y to the 5th squared. So to simplify this square root, we simply want to go through and pull out everything that we squared. So our answer here would be 8x cubed y to the 5th. We got rid of everything under the radical. Doesn't always work out that way, but in this case it did. So let's look at another example. I know that 75 breaks down to 3 times 25. And x to the 4th is the same as x squared. X squared squared. Y to the 8th is the same as y to the 4th squared. What about z to the 11th? Z to the 11th can be rewritten as z to the 1 times z to the 10. And z to the 10 can be written as a perfect square. So I'm going to say this is z times z to the 5th squared. So this is what I have under my radicals. So what can I pull out? Well, I can take a square root of 25. So I'm going to bring 5 to the outside. This is a squared function. So I'm going to leave my x squared. Here's another one, y to the 4th squared. So I'm going to bring out my y to the 4th. This z has to stay over here, but z to the 5th squared can come out. Okay, so I pulled out 5x squared, y to the 4th, z to the 5th, but I still have a 3 and a z. So I'm going to leave those under my radical. So my simplified square root would look like this. 5x squared, y to the 4th, z to the 5th, times the square root of 3z. Let's do a couple more. Okay, 144, x to the 8th, y to the 10th. Remember, break down what is a perfect square. You could also do this with cube roots or fourth roots, but today we're just working with square roots. So this becomes 12 squared. This becomes x to the 4th squared. This becomes y to the 5th squared. Okay, so now everything that has a squared beside it is coming out. 12 x to the 4th, y to the 5th. I took everything out because everything had a square beside it. And we're done. Okay? Let's do another one. Then we're going to move on to some tricky ones. 99 is the same as 9 times 11. And of course we know that 9, well, is 3 squared. Okay, a to the 4th is the same as a to the 2nd squared. B to the 10th is the same as b to the 5th squared. And c to the 14th, well, that's c to the 7th squared. So what can I pull out? My 3 squared, my a squared, my b to the 5th, my c to the 7th. But I still have this 11, so I'm going to write it under a square root symbol. Okay, so when do we apply this? Aside from just doing problems like that, we would use it sometimes when we use the quadratic formula, and we might end up with an answer like this. But we can look at this and tell it's got to break down some more. So we want to break this down. So I'm going to leave my 10 where it is, but I want to break down my square root of 50. The square root of 50 is the same as 2 times 25, and we know that 25 breaks down into 5 squared. So I can simplify this square root by pulling out my square roots. So now I'm going to pull out this, and I'm going to have 5 square roots of 2. I still have my 10 over here and my 5 down here. I can do more simplifying before I get my final answer. 10 divided by 5 is going to give me 2. 5 divided by 5 is just 1, so I end up with 2 plus square root of 2. So instead of dealing with this, what I'm looking at is just 2 plus the square root of 2. Okay, let's do one more. This time we have the square root of 18. Square root of 18 can be broken down into 3 times 9. And of course 9 is 3 squared. So I can rewrite square root of 18 as 3 square roots of 3. So now let's bring it back over here. Negative 2 plus 3 square roots of 3 over 4. To make this easier to look at, you can break it down into 2 over 4 plus 3 square roots of 3 over 4. Now I can't do anything here. 3 and 4 don't simplify, so that's going to stay. But this I can make negative 1/2 because both are divisible by 2. So that's going to make our final answer negative 1/2 plus 3 square roots of 3 over 4. And that is how you simplify square roots.